Hi students, I am Professor Padwar Arti Madhukar. See the chapter Chemical Kinetics, third order reaction, in which energy of activation we are seeing. Next point, content in which introduction, formula, temperature independence and the relation to Arrhenius equation, negative activation energy and catalyst. First we will see introduction. In chemistry, activation energy is term introduced in 1889 by Swedish scientist Sven Arrhenius to describe the minimum energy which must be available to the chemical system with potential reactants to result in a chemical reaction. Activation energy may be also defined as the minimum energy required to start a chemical reaction. The activation energy of the reaction is usually denoted by energy of activation EA and given in units of kilojoule per mole or kilocalorie per mole. Activation energy can be through of as a height of potential barrier. Sometimes it is called as energy barrier. It is separating two minima of potential energy of reactant and product of the reaction. For a chemical reaction to proceed at a resonant rate, there should exist an appreciable number of molecules with translation energy equal to the or greater than the activation energy. Then the formula for temperature effect of Arrhenius equation, K is equal to A raised to minus EA upon RT, where K is the rate constant at temperature T. EA is the activation energy. R is the energy gas constant, that is 8.3145 joule per mole per Kelvin. T is the Kelvin temperature. A is the collision frequency factor. Next formula of Arrhenius equation is ln K is equal to ln A minus EA upon RT, where ln K2 upon K1 is equal to minus EA upon R in bracket 1 upon T2 minus 1 upon T1. Next point is negative activation energy. In some cases, rate of reaction decreases with increasing temperature when following an approximately exponential relationship. So, rate constant can still be fit to an Arrhenius expression. This results in negative value of EA, that means energy of activation. Elementary reactions exhibiting these negative activation energies are typically barrier-less reactions in which the reaction proceeding relies on a capture of molecule in potential well. Increasing the temperature leads to reduced probability of colliding molecule capturing one another with more glancing collision, not leading to reaction as higher momentum carries the colliding particles out of the potential well, expressed as reaction cross section that decreases with increasing temperature. Such a situation no longer leads itself to direct interpretation as the height of the potential spots. Next, last point is catalyst, a substance that modified the transition state to lower the activation energy is termed as a catalyst. A biological catalyst term an enzyme. It is important to note the catalyst increase the rate of reaction without being consumed by it. In addition, while the catalyst lowers the activation energy, it does not change the energies of original reactants or products. Rather, the reactant energy and the product energy remains the same, and only the activation energy is altered or lowered. Thank you.